Llama is an advanced AI tool that allows users to easily set up and run large language models locally. With Llama, users can leverage powerful language models such as Llama 2 and even customize and create their own models. Llama bundles model weights, configuration, and data into a single package defined by a model file. It optimizes setup and configuration details, including GPU usage. Good day, guys. My name is Melvin Satishan, and we are gonna discuss about Llama. Before we move on to detailing the Llama features and their execution part, we want to define an infrastructure. So let's build a containerized Llama platform to run our Llama model. For that, let's open a PowerShell. We are going to install a Docker run -it Python. So minus p 11434 is the Llama port. 11434 is the Llama container port. So 11434 is the port in the base machine that we are going to define, and the another one we have to create for our Jupyter notebook. Okay, so Python, we are going to download the Python container image from the Docker repository, and we are going to execute a command bin bash. Right now the container is up and running, right? So we will do apt get update to update the repository. Well, the repository has been updated. Next we have to install pip and vim. So pip is for installing the Python packages, vim is for vi editor. Okay, so apt install vim and pip. Perfect. So I'm gonna give yes, and indeed it may take some time. So in the meantime we will do a couple more things parallelly. Okay, let's open another terminal, Docker container ls. Here we are going to do docker xx -it /bin/bash. Okay, so we grabbed the console from that. Now we have couple more transactions. First thing, we need to download the Llama model. For that we have to go to llama.com, download Linux. So if you go to llama.com, let's forget about the download, llama.com, here we have the download, and indeed here we have the Llama model software. Let's say since it is ours is Linux container, we are selecting the Linux version of that, and we will copy that and we'll go to / let's copy this to root, or let's do one thing, cd /opt mkdir utils cd utils. Okay, so here first we are going to install Llama. Okay, now the Llama is being downloaded. We have one more thing to be done, so let's do docker container ls. So here docker exec -it dde /bin/bash. Let's grab one more console here and cd opt utils, and we have to download Anaconda. If you Google Anaconda, you will come to know that Anaconda is an integrated development environment If you install the Anaconda framework, on top of Anaconda, you can run PyCharm, Jupyter Lab, Jupyter Notebook, like that IDE plugins. Okay. So since we are installing the container version here, so let's install Anaconda's miniature version called Miniconda. Okay. So here is the document. I have provided all the links, the important links here, the supplementary utils. If you go here, you will get the Miniconda URL. Just copy that, and let's come here. We will do wget the Miniconda version. Okay, it's the Miniconda version is being downloaded. Let's look at, okay, in the meantime the vi editor has and as well as the pip package has already been downloaded. Well and good. Now let's open one more terminal. Here if you look at it, we have a virtual environment. If you look at here, we are going to create a virtual environment called libbox, and we are going to install all this dependent package in that virtual environment. Okay, so this is basically we will be creating on top of a Conda, Anaconda platform. So how do we do that? Okay, for that let's do this way. Docker Docker cp, and it is copied in desktop, then DevOps, and I have another folder called data science, then libbox, and lib.yaml to kde /opt/utils. Okay, I'm going to copy it into under opt utils. Okay, so this has been copied. Well, if we come to this part, okay, here we have already installed the Miniconda 3 latest Linux 64 sh. Okay, let's install this. For that, chmod +x Miniconda. Okay, now we will do /miniconda.sh -b. Guys, look at this. This -b stands for batch mode. In the sense, if you run the miniconda.sh in just like that, it will request you to accept the user license and all. Whereas if you give -b, it will not ask you to provide any end user license, or it will not interrupt you. Okay, and you have one more option. If you want to install it in your bin utility, you can do something like a -- prefix equal to then the path. You can define it wherever you want it. Okay, anyway, I'm not gonna give that part. I will install it under my root directory itself, so that I will source it from the root. Okay, so I'm just gonna do Miniconda installation. So the Miniconda path, if you look at the prefix path, is root Miniconda 3. Okay, and the installation is in progress. Well, let's look at it. Okay, here the Llama download has been completed, or Llama download has been completed, and it has been installed. Perfect. And if you look at it, it is listening through the port number 11434. Okay, that part is completed. Okay, great. Now okay, so here our Miniconda version has been completed, installation has been completed. If we look at now our next part is, we will go to vi. Let's do this way, /root Miniconda cd bin. If you go to the binary, you will be able to see the conda executable and Miniconda related commands and all. Okay, now what do we need to do? Let's copy this part first. Alright, so vi/etc/profile, we will just export a path here. Okay, I'm gonna define path equal to, let's path equal to shift insert. I will insert, okay, perfect, colon dollar path. So what this command does is, the dollar path is this variable, so it contains all this path strings, and additionally we are appending this Anaconda binaries to this path, and finally we are exporting this. Okay, so let's save this, cd. Now if you do where is conda, it's not showing anything, right? Now I'm going to source it from /etc profile. Okay, perfect. Now whereas conda, it shows root miniconda 3 bin conda, right? All right, so next is we have to do conda init. We are going to initialize the miniconda. Perfect, it has been initialized. Next step, we have to create a virtual environment using this Anaconda. Before that, let's do a commit this image, and then we will do the rest of this activities. Okay, for that we are here, and docker image, docker container ls. Okay, we have this container. Now docker commit DDE. Okay, we are going to commit the image. It may take some time, so in the meantime, let's take a short break. I'm pausing this video in order to keep this video short and sweet. Well, the container has been committed here. Now let's do this exercise, right? Docker image ls. If we look at it, we have a 9406. This is the container. So let's do a tag, docker tag 9406 to we will do NGDM, next generation delivery model. Okay, I'm just giving a name as NGDM. So colon 1.0.0. This is my first release. Okay, I have tagged this. Now docker container ls. I'm gonna delete this container. Okay, docker container rm dde. Perfect. Okay, I'll stop. For that, we may need to quit this. We need to quit this. We need to quit from here as well. Well, the container has been stopped. Next, we have to do docker container rm. Well, the next is we would be creating a new container using the new image. Let's say docker image ls. Perfect. So NGDM, it is visible here, right? So docker container run -it -p 11434 colon 11434 -p == colon == and NGDM colon 1.0.0. okay, /bin/bash. Look at here, our container is gonna spin with the newly created image. Perfect. So something has happened. Okay, well, this is, I have given an additional 8. Okay, and let's do one more thing. --name ng data science. Let's do data science box. Let's give this name as well. Perfect. It is up and running. Perfect. Okay. Now, if I look at it, where is Conda? Anaconda is visible here, right? Perfect. Now, one more thing. Now we have to create a virtual environment. For that, we will go /opt utils. We are here. We have a configuration file libbox.yaml, right? Now here we will do conda create. We will do conda env create -f libbox.yaml. Excellent. So the virtual environment creation is in progress. It may take another 5 to 10 minutes. Let me pause the video for a second and we'll be back soon. Excellent. It seems our package has already been installed successfully. We are good now. Okay. Now the next step, we have created the virtual environment. The next step is to activate this virtual environment. For that, conda activate libbox. Okay, any name you can provide, not a big deal. So that you have to define it in your declaration file. Okay, so in this libbox is our virtual environment. If you look at now, the system is in libbox virtual environment. Well, let's install Jupyter, Llama, and let's install PySpark and PySpark all. Let's install all dependencies as well, and Jupyter I would say all dependencies. Install. In this we are installing a bunch of packages, so it may take another couple of minutes. Let me pause the window for a while. It seems the packages are successfully installed. So the next step is we have installed the Jupyter notebook, and we have installed the necessary Llama packages and all. Well, the things are almost ready. Okay, now let's do this way. Llama serve. This will activate the Llama service. Okay, if we look at it, we can see that these APIs are active. Where it is active, it is exposed to the local host. Since we have already enabled the node port here, if you look at the container, respective container in the Docker engine, if you look at it here, this is our container, and if you look at it here, we have this node port configuration. Both 11434 is exposed as well as 8888 is exposed. So MN 11434, these two ports 11434 is active. Well, so we will go to the console back. The port is up and running. Perfect. Now let me open one more window here. I'll go cls docker container ls docker exec -it c7993/bin/bash. Perfect. So we are here. So here as well we have to do conda activate libbox. Okay, now we are in the libbox environment. Perfect. Here we need to check one thing. The port number 11434 is up and running, right? We have already downloaded the Llama. Now let's try to interact manually, right? For that, Llama run Llama 3.2. So we are gonna discuss each and every component in Llama 3.2 in detail in the upcoming session. All right, so it is pulling the manifest. It supports up to some trillions of algorithms as far as I know. I am yet to check the matrix, so those details we have already captured and put it in our Git repository readme document. Now it may take another couple more minutes, so let's take a break again. It has already downloaded all the necessary manifest and it's up and running. Now let's say that, let's ask a few questions, right? So can you please explain how many algorithms Llama 3.2 is having? Okay. Very nice. So it is providing certain details, right? Indeed, it won't provide us the confidential details, but overall its features and all those details will be provided. Similarly, we can interact with the Llama using this shell, right? That is one use case. Indeed. Okay, I was saying the Llama 3.2 model has approximately 350 billion parameters. Yes, that is what I would like to share with you. Okay, so here is the interactive shell. So that is not our expectation. If we go for some application, or if we go for if we are going to interact or integrate it with applications, we need this interactive shell is not gonna work out. We have to interact with the API, so we should access it programmatically, and we should post certain payloads and receive certain responses. Okay, now in this case we are going to exit from the shell. Perfect. Here our next plan is, we are in a libbox, right? Let's open a Jupyter notebook. So for that, Jupyter notebook hyphen no hyphen web browser hyphen IP equal to 0.0.0.0. So I'm exposing it into the all network, and no browser in the sense it should not start the default browser within the system itself, so that it will throw some error. Indeed, now also we are supposed to get an error. Let me show you that. It will yes. So since I executed as a root user, it is not allowed. So we have to do a bypass argument. Allow hyphen root. Perfect. So our API is ready for the Jupyter notebook. So let's go to the Jupyter notebook. Perfect. Just opening it. Just copy. Let's go to the browser. Okay, our notebook is ready. Now we will open a new notebook. Here is the prompt. Now in this, what we will do, import Llama. Okay, now here we have certain things. Let's do messages equal to, it should be a list, and it should be the list should contain the parameters in the form of dictionary, So we will give a minimum parameters, the role. What would be the role that it is going to handle? Let's give user. Next is content. What content it is uh, going to post it into the Llama endpoint. So can you list the can you please provide the list of European countries? Okay, this is our question basically, right? We are not gonna give a stream. Let's do stream is false. Okay, we have provided stream is false. Perfect. So that part is fine. Now response equal to Llama dot chat and the payload is going to be messages equal to, we have to provide the above statement. So I'll be giving that. Pretty straightforward, right? And one more thing we have to give, model equal to. So let's give that parameter as well, model equal to Llama 3.2. Perfect. So we have provided the model and the desired statements, right? So here the model is going to be model. Okay, perfect. So it's time to get the response, right? Okay. A quick thing I will in the meantime I will show you. If you look at it, the CPU is 50% in the container and the RAM is 7.8. Still the CPU utilization remains as it is. Okay, if I minimize the window, we are yet to get the response. That means something is happening in the backend. Okay, keep an eye on this CPU parameter. Let it process. Also, one more thing I would like to show you. Okay, there are certain post requests, right? So in the post request, it is responding to respond with the 200 code. That means those requests were successful. Okay, now CPU is 0. On the other hand, we have received the response. So this is basically the module based interaction. So for that we have to download the Python module or Llama, and suppose you have a web application where the end user is providing certain questionnaires or something. So that questionnaire can be ingested using certain events in your React hook. So that events can be passed to the backend using a fast API, and the fast API should have an argument like a event message body. That body should be placed here. So that can be, then it can do this kind of a query, so that it will give us the response. Especially in this response, we will be concerned on this content. So in this content, I would like to show you one more parameter here, response dot message dot content. Okay, let me execute this once again just to give you much more clarity. So here it's again 49.9%. This is one of the use case that I would like to share with you. Okay, this is the MVP. Very basic stuff. Indeed, we will crack more use cases in the upcoming sessions. All I need is, we have to set up an infrastructure, we don't want to install it in our local desktop or MacBook or wherever, because then again we need to uninstall all the dependencies. I don't want to mess up our workspace. It should be clean and neat. So for that reason, we are installing all these things into a container, and we are packing it and exporting it into the Docker repo. So whoever is interested, they can just do a pull from the repository, plug and play it on top of your Docker engine, do whatever the exercises you want. Okay, well, pretty cool, right? So that would be much more aligned with our microservice philosophy, I would say. Okay, so this is the answer that we have received. Perfect. Now if we look at it, as I told you, it's again our modular model. Next, let's deal it with our traditional Python request model. Okay, import space requests are as you are knowing. Now we need to define a parameter, http :/local host. Rather than local host, we will give 127.0.0.1 because it may conflict with the IP version 4 and all, since I haven't disabled here. So 114.3.4 is the port, and /API/chat is the API endpoint. Then here we need another parameter called header. So header, we always declare it in the form of dictionary. So here we should define content hyphen type. Okay, that can be application/JSON. Okay, so header is there. Now next is payload. So before that, let's do this way. Message equal to, as you know, it is going to be a list. Within that list we will have a dictionary. In that we need to define the role. Role is going to be user. Then we need content. The content is going to be list out the European countries. Okay, that's it. Here, unlike the modular model, we are not going to define the stream here. That will be declaring it separately in the payload. Okay, now we need to define the payload. Payload equal to, before that, one more thing, let me define model equal to string Llama 3.2. Perfect. So we defined the model as well. Okay, so next is going to be our payload. Payload should be in the form of dictionary. Well, so let's assemble all these things. Right here we need message that we are going to pass. So it should be a string. Message is going to be message, and model is going to be model. So, and here we have to define stream. Okay, we took it outside because in the payload this particular argument that we need to pass false. Okay, so that part is completed. Next is we are going to do response equal to request dot post, and here URL equal to URL, because I'm selecting supplying this URL parameter and the value as URL. We have already declared it here. Now header equal to header. It has already been explained in or declared in the above segment. And payload, so for that JSON, we have to give JSON. format. We have already defined it above, so that is going to be the dictionary that we are going to define it here. Perfect. So all the required ingredients that we have provided. Let's do a print here, print response. Well, so let's execute this. Oh, interesting. It's throwing some error. Okay. Request so dot response request dot post URL equal to URL, header equal to header, JSON equal to payload. What is the error? Header. Okay, in the header there's an unexpected keyword argument header. Okay, understood. So it should be application slash JSON. Let me check that, please. Okay, so okay, let's look at it. Header part. Excuse me. Excuse me. Right. All right. So the problem was we were supposed to provide headers. It was showing only header. I don't know why the Jupyter notebook was showing header. So headers is the right parameter we were supposed to give, and we have already declared the header here, so that has been assigned here. We received a 200 response. So let's give JSON in the form of JSON and re-execute it. We have received, yes, perfect. We received the response JSON, right? Now we need to go to the message. All right. Dot. All right, so the done reason content is missing. Content list out the countries. Perfect. Yeah, we haven't done anything wrong in it. It was supposed to provide the output. Okay, application JSON. Well, so when we troubleshoot further, let's do once again. Okay, model Llama 3.2 created at and message assistant content. Okay, content is missing something. Okay. What could be the reason? Okay, here messages, because it's a list of dictionaries, so here it should be plural. Okay, now we are going to receive. All right, so let's look at the query part. So 50%, perfect. Perfect. So we have received the response. So in the interaction perspective, our Llama is ready. I mean, we have installed all the necessary utilities, I would say. We have already installed the PySpark and NumPy, Pandas, and the essential data science engineering packages. So we would be repurposing this for our data science sessions as well. Now let's do one more thing, please. Let's check once again whether we have installed the right. We'll do here itself, terminal. Here we will go to bash. We will open conda, activate libbox, and from here we have to install pip install pandas, all dependencies, numpy, all dependencies. What else do we need? Pandas, numpy, and scooping things. We don't need it. So let's install all those packages as well, since we are about to commit it. So these also we required in our data science session. Additionally, we will install Boto3 libraries as well, so that we can explore more streaming techniques as well with Amazon MSK or Kafka, whatever it is. So again, it is going to take much more time, so let me pause the video for a minute. So we have installed all the necessary Python packages as well to this libbox virtual environment. All we need is make sure that once you spin the container, we should switch to the bash, and from there we have to activate this libbox virtual environment. From there we have to use the Llama as well as our Jupyter notebooks, so that we would be able to perform transactions using all the installed libraries and modules. Okay. Now one last step that we are going to perform is, let's commit this image and let's export this to Docker repository. So Docker container ls. Now Docker commit C793. Okay, I'm going to commit this, and indeed it may take another couple of minutes, so let me pause this video for a minute. Alright, so we have created the new image 2df. So let's label it Docker tag 2df to Melvin Satishan /ngdm colon 1.0.0. I have done this. Now Docker push Melvin Satishan /ngdm colon 1.0.0. Perfect. I'm sorry for the typo. Excellent. Indeed, it may take some time, so I'll pause the window for another couple of minutes and we'll be back. Indeed, this image upload may take some more time, so I will close this video now and we will resume downloading the image and deep dive into more AI based exercises. Okay, thank you everyone for your time, and bye for now.